Hi everyone, this is Janine aka Janine The Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt to the circumstance really quickly, and that's why we want to extend our helping hand to you students to stay on top of your studies by running free and daily classes for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, we'll be covering geometry, so we'll just continue on from where we left off. And I believe we were talking about rectangles, and then we'll go on and discuss triangles. Okay, before anything else, I just wanted to make sure you guys can see my screen and also you can hear me coming through. So yeah, for today's class, we'll continue on rectangles because that's where we left off. And then triangles will be the next portion of this class. Okay, great. So I think we left off from here, right? So we were trying to fill out the measurements of the angles and depending on where they're found. So I think I vividly remember that we talked about this being 30 degrees. Now that I took a look at it, this should be 60 degrees because if you think about it, right, I think it was switched from what I remember. If you look at, let's say, triangle HEF, right? If you recall, you have your special triangles, which is the 30, 60, 90, right? So if you look at HEF, right? So if you know that this is 90 degrees, right, which will comprise your right angle. Now, if this was 30 and this was also 30, right? And well, that doesn't make sense because I guess a triangle, right? Even though it's a right triangle, it needs to sum up to 180 degrees, right? Your interior angles need to sum up to 180 because if you have 30, 30, that's 60, and then you have 90, that doesn't really sum up to 180 degrees. So this has to be 60, and then this has to be 30. And then on the other hand, if you look at this triangle HFG, you would have 60, and this is 30, right? And this is 90. So it actually adds up to the correct 180 degrees, which is the interior angles, right? The summation of the interior angles of a triangle. Great, so HEF, we said it was 90 degrees, and then you have FHG, which was 60 degrees. Sorry, HFE, yeah, it's 60 degrees. I think this was 30 degrees, so make sure to correct that from our previous class. And then we filled this out, right, which was 16 and 13.8. Okay, great. So let's proceed to the next question. Okay, so we still have a rectangle and we have A degrees, C degrees, B degrees, 65, and all of the variables, right, on the sides. So in our length, we know that this is 8, therefore this has to be 8 as well, right? Because the opposite side of a rectangle, they're actually congruent, right, if you recall. And then if you have D, right, the opposite side would be 5, therefore this is also 5, right? Because opposite sides of a rectangle, they're congruent, meaning they're exactly the same dimension. Okay, great. So now that we look at this, right, so we know that in a rectangle, it's going to be 90 degrees, right? The corners over here, right? All of your angles, well, there's only 4 angles, right? As you can see, that means they need to sum up to 90 degrees, right? They're complementary. Remember that term? Because they add up to 90 degrees, therefore it needs to be complementary. So if you have 65 over here, therefore in order to find A, right, you would just take 90 minus 65. So that's equal to 25 degrees, right? Okay, so now that you know that this is 25 degrees, right, you can actually apply your Z pattern if you remember. So it's your alternate angles. So if you have this, can you guys see this? So if you know that this is 25, if you apply your Z pattern, right, whatever this angle is, that needs to be congruent with this angle, right? this and this would be 25 degrees, right? And then on the other hand, if you look at this pattern, right, over here, so this, and this, if this is 65 degrees, therefore this needs to be 65 degrees as well. Okay, great. I don't think that was too bad. Okay, great. Moving on to the next one. Okay, so now we have a rhombus, right? So as you can see, if you recall right off the bat in a rhombus, if you have your diagonals, right, which as you can see here, they're actually equal to one another, and on top of that, they form a perpendicular bisector. So when I say a perpendicular bisector, meaning they create a right angle at their point of intersection, right? So this is, okay, great. This is supposed to be a right angle. I don't really know why this is, okay, yeah, that's supposed to be a right angle. I don't really know why this is not making me form a straight one. But yeah, this is supposed to be a right angle. And we know that this is also a right angle, this as well, and this as well, right? And what do we know about the sides of a rhombus? They're actually equal to one another, right? So if you have 14 here, you know that this is going to be 14, this is also 14, and this is also 14. Right? Because the similarities between a rhombus and a square is all sides are equal, right? So if this is 14, all of your four sides will be 14. Okay, so now we know that, right? And this B over here, you know that this is 12, right? Therefore, because it's a rhombus, right, the diagonals are supposed to be equal to one another. Therefore, this is also 12. Okay, so finally, I think we only have C left, right? Okay, so first of all, we know that the opposite angles in a rhombus, right, they're supposed to be supplementary, right? So if you know that this is 60 degrees, right, in total, therefore, how would you find this angle in total? I know there's 60 degrees here, but that doesn't really tell us anything for C degrees. So in that case, if you know that this is 60 degrees, because you know that the two opposite angles, right, I guess in total, not just 60 degrees, right? You know that this is actually supplementary, right? So first, you're going to take 60, right? And you know that this must be supplementary. So 180 minus 60, we know that this is 120, right? So this whole thing is actually 120, right? So in order for you to find C degrees, all you do is you take 120 minus 60, right? Which will give you 60 degrees, right? And it's just a coincidence that these two are equal, so they're not always going to be equal. Yeah, so if you're having this assumption right now, are they always going to be equal? No, it really depends. Okay, I think that's it for this question. Okay, yeah, that's it for this question. So now we're going to move on to the types of slope. I know there is going to be a little bit of an overlap between geometry and algebra 2, because at the end of the day, they're both math. They're both the fields of math, right? So okay, so first maybe we can define what it means to be a positive slope, what it means to be a negative slope, zero, and undefined, right? So we all know by now that if you have a positive slope, right, you need to look something like this. So this is your X and Y axis, and if it's a positive slope, right, you need to be found in, so this is your quadrant 1, 2, 3, and 4, right? So you need to be found in quadrant 1 and quadrant 3. Does that make sense? So that's when you have a positive slope, and when you have a negative slope, right, you need to be found in quadrant 2 and quadrant 4. Great. So now that we have that, we're looking at 0, right? So what does it mean when your slope is 0? It's literally a horizontal line, right? So horizontal line. So in that case, if we have a horizontal line, let's say we have y is equal to 2, right? So this is 2. So we just have a constant, right? Y is equal to 2. That means this is a slope of 0, right? And then when we have something that's undefined, that means we're looking at a vertical line. Okay, let's say it's x is equal to, this could be 3, right? So if you have x is equal to 3, right? Or it doesn't have to be x is equal to 3. It could also be x is equal to -3. So don't think that it's supposed to be a positive number, right? This could be y is equal to -2, and this could be x is equal to -3. Like, it doesn't have to be a negative number or a positive number for you to be 0 or undefined. As long as you know you're a horizontal line, and if you're a vertical line, that means you're 0 and undefined respectively. Okay, great. So, yeah, let's get to the following question. So we need to identify the slope as positive, negative, 0, or undefined, right? So we know that we just talked about if you have y is equal to 7, right? If you have a slope that's 0, therefore you're going to have a horizontal line, which is y is equal to whatever value, right? It could be fractions, it could be a negative number, it doesn't have to be an integer, right? So if you have y is equal to 7, therefore the slope is equal to 0. I should have wrote 0 instead because we're not supposed to find the value anyway. Okay, so if you have 2x plus 3y is equal to 12, right? This is what you call the standard form, right? So first of all, what is the standard form of an equation of a line? Okay, standard form. So if you're looking at the standard form, that means you need to take ax plus by is equal to c, right? So if you have your x, your y, and you have a constant respectively, that means you're in the standard form. So because this is in the standard form, right, if we're finding what the slope is, right, in terms of its numerical value and its sign as well, we can't really tell just by looking at this figure over here. So what I tell my students is it's easier for you to organize this in a way that you're going to see it in the form of the slope-intercept form, right? Just because if you have the slope-intercept form, as the word implies, right, it tells you what the slope is. So if you have 2x plus 3y, which is equal to 12, that means you're just going to isolate y, right, on one side of the equation, right? So you have 3y, moving 2x to the opposite side, you get negative 2x plus 12, dividing both sides with 3. So y is equal to, so in this case, maybe we can move this here because I want to have enough space for part C. Great, so we have 3y is equal to negative 2x plus 12 divided by 3, so we know that this is y, and this is equal to negative 2 over 3, and this is x, and as you can see, you have positive 12 divided by 3, which is positive 4. So yeah, as you can see, you have a negative slope, right? Because this is in the form of y is equal to m. Remember, in math, we denote the slope as the variable m. And you have negative 2 over 3, so that means this is negative. So your slope is negative. And this is plus b, right, which is your y-intercept. Okay, so now for part C, right, as you can see now it's in the slope-intercept form, so we only have to do less work, right, because they're explicitly saying that your slope is negative 1/2, right? So this is, we know, negative, right? So this is a negative slope. We don't have to rearrange the equation. Okay, great. So if we have x is equal to negative 4, right, what did I say about x is equal to negative 4? We know that this is a vertical line, therefore this must be undefined, right? Yeah, anytime you have an equation which is x, that's undefined, and whenever you have an equation which is y, therefore it's only going to be 0, no matter what. Okay, so again, this is in standard form, so we need to rearrange this, right? So if you have negative x plus 2y is equal to 10, we need to isolate y on one side of the equation, therefore we get 2y, and then we move the negative x to the opposite side of the equation, we get positive x, and this is plus 10. Dividing both sides with 2, right, we get y is equal to 1 over 2x. One over 2x plus 5, right? So as you can see, just by looking at this equation, x is now positive, right? or the coefficient of x rather, is now positive, right? So in that case, we know that the slope is going to be positive. So yeah, it's really hard to tell just by looking at this, because here your coefficient for x is actually negative. Okay, now we have y is equal to 1/2, right? So y is equal to 1/2 is a horizontal line. Did I just say line? Okay, horizontal line. Y is equal to 1/2, right? Therefore, if it's a horizontal line, that means your slope is 0, right? Okay, let's proceed to 2x minus 2y is equal to 16. So if you have negative 2y, which is equal to negative 2x, and this is plus 16, dividing both sides with negative 2, right? So in that case, you would get y is equal to just positive x, and this is going to be negative 8, right? Because it's taking 16, positive 16 divided by negative 2, which is negative 8. So as you can see, the coefficient of x, which is the slope, is positive, therefore this is positive. So it has a positive slope. This also has a positive slope because it's already in the slope-intercept form, so you don't really have to do much for letter H. So this is positive. Now you have x is equal to negative 5 over 4. So if you have negative 5 over 4, that means if it's an x equation, it's undefined. So looking at J, right, it's the standard form, therefore we need to isolate y. So we have 4y is equal to negative 5x plus 20 divided by dividing both sides with 4. So you have y is equal to negative 5 over 4x, and this is plus 5, right? 20 divided by 4, that's plus 5, so this is a negative slope. So for this, we just have negative 2y is equal to negative 3x, and this is plus 12, dividing both sides with negative 2. You get y is equal to 3 over 2. Now it's positive, right? Because negative 3 divided by negative 2 is positive 3 over 2x. And finally, this is 12 divided by negative 2, which is negative x. Sorry, negative 6 rather. And this is 3 over 2, so this is positive. Now, if you're looking at 4x plus 6y is equal to 18, you would have 6y, which is equal to negative 4x. This is plus 18, dividing both sides with 6. You get y is equal to, so you can cancel this. So this would be 2, and this is 3. So this is negative 2 over 3x. And 18 divided by 6 is actually positive 3. Therefore, this has a negative slope. This is also negative because you're looking at negative 5x, right? So negative 5 is your slope. Okay, so now that we've kind of went over the different types of slopes, right? So we know when is it positive, when is it negative, undefined, and 0, right? So now we actually need to find the numerical value of the slope, right? So we do have a couple of questions here. So for part A, it says we have a line containing these points. So we have 3, 6, we have 1, negative 4. So if you recall, whenever you're trying to write the equation of your slope, right, you have this y2 minus y1 over x2 minus x1, right? So this is basically your coordinates, right? So you know that you're given 2 points. So the first one being x1, then you have y1, then this being x2, and this is y2, right? So all you have to do is set up this equation. So you take y2, which is negative 4, and you know that there is a minus sign there. So you're going to have that minus sign, and this y1 is actually 6, so you're going to have a 6 here, dividing this with x2, so x2 is 1, minus x1, which is 3, right? So negative 4 minus 6 is negative 10, and you know that 1 minus 3 is negative 2, right? A negative number divided by a negative number would give you a positive number, therefore this is 5. So the value of your slope is actually positive 5, and it's a positive slope. Okay, so here we need to find the slope of each. Yeah, so all we have to do, because it's in the slope-intercept form, is we just have to write 1 over 3, and that's it. Okay, so now we have 4x plus 6y, which is equal to 10, right? So because it's in the standard form, you need to rearrange your equation. So you would have 6y, which is equal to negative 4x, and this is plus 10, right? And you're going to divide this with 6 for both sides. Therefore, you're going to get y is equal to, so this and this, so this is divided by 2, so this is 2 and 3, so this is negative 2 over 3x. And finally, you have plus 10 over 3. So your slope is actually m is equal to negative 2 over 3. Okay, so let's proceed to x plus 3y, which is equal to 12. So you would have 3y is equal to negative x plus 12, dividing both sides with 3, right? You would get y is equal to negative 1 over 3x, and this is plus, so 12 divided by 3 is positive 4, right? Therefore, your slope is equal to negative 1 over 3. So for part E, you have 3x plus 6y is equal to 12, right? So you would have 6y on just one side of the equation, and you're going to move 3x to the opposite side. So you would get negative 3x plus 12, dividing both sides with 6. Therefore, you're going to have y is equal to, so this and this would be negative 1/2, right? X. And this is plus 2. Therefore, your slope is equal to negative 1 over 2. Okay, so for this last question, we need to find the slope again. Remember, because you're given a series of points, right? Or in this case, you have this and this. So you know that this is x1, this is y1, this is x2, this is y2. Therefore, in order to find your slope, you would have y2 minus y1 over, yeah, this is supposed to be y1, over x2 minus x1, right? So your y2 is negative 4. You have a negative sign over here because of your equation, and then you have y1, which is 5, over x2, which is 3, x1 is minus 3, right? So as you can see, you're going to have negative 9 over 3 minus 3, which is 0, right? So can you actually have negative 9 divided by 0, right? So even if you try to do long division, right, you're going to see that you're still going to get the same 9, right? So it's going to be undefined. So this is actually undefined. Because you can't have a number divided by 0, right? You can only have 0 divided by a number, right? So let's say if you have 0 and 2, right? 2 times 0 is still going to be 0. However, if you have a number divided by 0, that's going to be undefined. So you cannot have a slope that's a numerical value, therefore it's undefined. Okay, so now we're going to take a look at if two lines are parallel, perpendicular, or neither, right? So, okay, and it says we need to show our work. So we have line A, which contains the points 0, 3, 3, 1, and line B contains the following points, right? So for two lines to be parallel, they need to have the exact same slope, right? But if it's perpendicular, it needs to be the negative reciprocal or the opposite sign, right, of the other line. So let's say we're looking at line A, right? So for line A, in order to find its slope, you would have y2 minus y1 over x2 minus x1, right? So this is x1, this is y1, this is x2, and this is y2. So I'm taking 1 minus y1, which is 3, and then you have x2, which is 3 minus 0. So as you can see, this is going to be negative 2 over, so this is 1 minus 3, which gives you negative 2, and then you have 3 minus 0, which is 3, right? So as you can see, the slope is negative 2 over 3. And then if you're looking at line B, right, you have a slope which is equal to, So x1 is over here, this is y1, and this is x2, and this is y2. So y2 is -5, and then your y1 is actually 4, right? So -4. And your x2 is -7, then your x1 is, so this is -1. So just remember that because the formula has the negative sign, right? Don't forget to actually distribute that to your following term, because I know a lot of students, they would just drop the negative sign, which was part of the equation. So yeah, just remember that this -1 has an existing negative sign. Therefore, if you have this negative sign as a part of the formula, you would have to distribute that. So this is -9 over, so this is now -7 plus 1, so that's -6. Yeah, let's see. So as you can see, if you have -9 divided by -6, you're going to get 3 over 2, right? So if you take a look at line A and line B, so for line A, it has a slope of -2 over 3. And for line B, this is 3 over 2. So I guess by now you need to know that these two, right? If you take the reciprocal of this, if you have -2 over 3, right? So you take the negative reciprocal, so that means if you have a negative sign, then you have a negative sign that becomes positive, and then you take the reciprocal, which is 3 over 2. Therefore, you're going to see that this is positive 3 over 2, right? Therefore, we can say line A and B are perpendicular. So this sign means they're perpendicular. Because the slope of line A is the negative reciprocal of the slope of line B. Okay, now we're looking at line Q and line R, right? So as you can see, we know that line Q has a slope of +3, and for line R, right, it has a slope of 1 over 3. So it's not really the negative reciprocal, right? And it's not the exact same slope. Therefore, they're not parallel, and it's also not perpendicular, right? Because as you can see, it's not -1 over 3. Therefore, line Q and R, right, are neither. Okay, so let's look at line A and line B. Okay, so interestingly, they're actually using horizontal lines here, right? So they're using 4, right? So 4 is right here. And then they're using y is equal to 2, right? Actually, let's change line B into x is equal to 2, right? So if you have x is equal to 2, you're probably wondering, okay, so one of them has a slope that's undefined and one of them has a 0 slope, right? So that's probably what's going on in your mind right now. So if you draw this line, yeah, and this is supposed to be a vertical line, right? Okay, so there we go, right? As you can see, you're forming a perpendicular bisector, right? So where they're intersecting, right? The point of their intersection, you're forming a right angle, right? Therefore, you can say that line A and B are perpendicular, right? Because even though your slope for line A is 0 and your slope for line B is undefined, right? They're still forming a perpendicular line, right? Because the question here is determine if the two lines are parallel, perpendicular, or neither. Okay, so for line G, we have 3x plus 2y is equal to 10, and for line H, we have y is equal to -3 over 2x minus 5, right? So as you can see, for line H, we have a slope of -3 over 2, And for line G, maybe we can rearrange this equation. We would have 2y, which is equal to negative 3x, and this is plus 10. Dividing both sides with 2, you're going to see that this is y is equal to negative 3 over 2x, and this is positive 5, right? So negative 3 over 2 is also the slope of line G, right? So line G has a slope of negative 3 over 2. And because you have the same slope, therefore you can say line G and H are parallel. Okay, so what we can do for the next few questions, so I wanted to kind of stop midway for talking about lines when they're perpendicular, when they're parallel, and when they're neither, right? And also the different types of slopes. Because I think whenever you're trying to study, I think it's good to kind of mix all the concepts together, especially when you're prepping for your exam, right? Just so you know that you're able to just look at a question all of a sudden and you know what to do, right? So that's why we're now going to triangles, right? So for next class, we'll just continue on with the slopes and some of the triangles, right? So it's sort of like a mix, because otherwise this would just be all about slopes, right? Which can be very, I would say, overwhelming because it's the same concept over and over. Okay, so let's go to triangles now. So we're talking about triangle centers and also the special segments in triangles as a result of their triangle center. Okay, so first of all, let's see. Okay, great. So we now look into centroids and medians, right? So yeah, first of all, where is your centroid, right? So your centroid is actually over here. Can you guys see this? Yeah. So as you can see, what happens in having a centroid, if a triangle has a centroid, it actually creates medians, right? So medians just mean if you have this intersecting, so it starts from a vertex, right? So what a median is it's a line segment that connects a vertex to the opposite side, right, of a triangle. So that's what a median is. And as a result of that line segment, right, crossing, right, or connecting from one vertex of a triangle, right, to the opposite side it creates this equal side, right? So this is where the midpoint exists over here. So this is a midpoint. So what a centroid has, right? And if you're looking at a median, right? So this is a median. So this is the line segment, right? So if you have, let's say in a triangle, you have 3 medians intersecting, right? At that point, you call this a centroid. So that's your centroid. And then what a median does is you have a line segment starting from a vertex of the same triangle, right, connecting to the opposite side, you create a midpoint. So this is your midpoint. And what's a midpoint, right? You know that in a line segment, if you have a midpoint, that means it creates 2 equal sides. Okay, hopefully that was clear. Okay, so this is a line segment. I'm just trying to think if we can fit this here. Okay, let's just fit this here. So we have a median. So this is basically a line segment. I think we can just write it under here. Okay, so this is a line segment that connects a vertex So you have this coming from this vertex, or even here, right? This is the vertex, and then basically, yeah, connects a vertex to the opposite side. So you have a vertex to the midpoint. Okay, so 2 important things that you need to remember. If you're looking at medians, right, that means you're starting from a vertex and you're moving towards the opposite side, you create a midpoint, right, over here. On the other hand, you can also have a median over here because this is also a vertex of a triangle, right? So you can only have 3 medians in a triangle because, as you know, you only have 3 vertices, right, in a triangle. So if you have a line segment starting from this vertex, when you connect to the opposite side, right, you're going to create a midpoint over here, and there's 2 equal sides. On the other hand, if you're starting here from this vertex, right, if you're connecting from this vertex to the opposite side, you're going to create 2 equal sides, right? As you can see, there's 3 tick marks. Okay, so that's what a centroid is. So now we're going to look at perpendicular bisectors. So let's see. Okay, so as you can see, we have what you call a circumcenter, right? So first of all, what's a circumcenter? So a circumcenter is basically you're going to have just a circle, right? You call this a circumscribed circle, right? So circumscribed. Oh my gosh. Okay, come on. So in math, what circumscribed means, basically you have a circle over here. Yeah, I know this is not going to be accurate, but you have a circle outside, right? And this is basically the center of your circle. That's what a circumcenter is, right? So if you remember the word circumference, right, it kind of sounds like it's a circle, right? The circumference of a circle. So yeah, it's related to having a circle, right, encompassing your triangle, right? And as a result, right, if you have this, it's going over here, here, and here as well, right? That means you're creating what you call a perpendicular bisector. So your perpendicular bisector, it's just a line segment that cuts a side, right? So you have this, right, starting from here. So you're cutting this triangle into 2 sides, right? So it's cutting this side and it creates a right angle. That's what a perpendicular bisector is. So it's a line segment that cuts a side of a triangle in half and makes a right angle. So it's really important to remember that we're talking about right angles because that's what a perpendicular bisector does, right? So you have this circumscribed circle. As a result, you're going to cut a side of a triangle into 2, right? But they don't necessarily have to be. Okay, actually, here's my question. Are they supposed to be equal to one another? Yes, because you're cutting a side, right? Can you guys see this? The tick marks over here. So when you're cutting your triangle into 2, it actually creates 2 equal sides as well, right? So if you have this, this is equal to this. If you have this perpendicular bisector, this is equal to this. And if you look at this, you have 3 tick marks over here, so it's actually equal. So it's very similar to a centroid in that sense. Okay, so if you have in center, right, all that means is your circle now is inside your triangle, right? So you call this an inscribed circle. So if you have an inscribed circle, right, that means your circle is inside your triangle. Yeah, it's supposed to touch the edges of your triangle. Okay, yeah. So you have that in your triangle, right? And if you have an in-center, what this creates is a perpendicular bisector, right? So if you have this over here, so this is going to cut this into half, right? So if you look at this triangle, I know it's a little bit hard to see, but you're starting from this point and you're cutting these two angles into two. So that's what an angle bisector is, right? It's not necessarily a right angle, right? Because if you were looking at the perpendicular bisector, it creates a right angle, but no. In this case, it just cuts the angle into half, right? And it's basically, yeah, they're going to be equal in this case, right? Because if you're cutting this into two, this is going to be equal to this whatever angle that is, right? So a line segment, so this is a line segment that cuts an angle, so an angle of a triangle into half, or in half rather. Okay, that's it. So when you cut it into two, right, that means this angle, if this is 20 degrees, this has to be 20 degrees as well. So that's for in-center, and let's proceed to orthocenter, right? So for orthocenter, this is basically right here. So that's your orthocenter. So the difference between a perpendicular bisector and an altitude, right, because they're very similar because they create right angles, is when you're looking at an altitude, it's basically starting at a vertex, right? Because for perpendicular bisectors, it's starting from a side, right? It's not starting from a vertex. So for altitude, right, it's a line segment that starts at a vertex. So yeah, it starts at a vertex as opposed to a side of a triangle and is also perpendicular to the opposite side. So yeah, for an altitude, basically it starts from a vertex, and for your perpendicular bisector, it starts from a side. And both of them, they create this perpendicular line right over here, or line segment, and you have this right angle to the opposite side. Okay, great. So that's for orthocenter. And interestingly, right, because, you know, in math, right, we like to use words, right? So if you recall, right, or if you probably know what ortho means, right? Or if you probably had braces before, right? If you so the reason why you go to an orthodontist, right, is because you want to straighten your teeth, right? So if you're looking at an orthocenter, this must be straight. Does that make sense? So that's why this is not like this, like the perpendicular bisector over here. So the perpendicular bisector, it's literally you can start anywhere, right? As long as you're creating that right angle. But for this, right, orthocenter, you need to start from a vertex. So it has to be a straight like line down, right? And then you create this right angle. Okay, yeah. Something to just keep in mind, right? I think it's just easier for you to remember if you try to connect the dots. So if you have this as an example, okay, so let's move on to some examples. So we have point A is a centroid and we need to solve for y, right? So what did we say about centroids, right? So if you're looking at a centroid, right, that means you have a line segment, or actually for medians, right? Because this is where your centroid is, that's point A. You're going to have medians, right? So your medians are starting from your vertex and they're basically connecting the vertex to the opposite side. And as a result, you create a midpoint, right? So what does a midpoint do? This means that this side is going to be equal to this side, right? So you can actually say that 5y minus 18 is actually equal to 3y plus 40. Right? And then you're going to have 5y minus 3y, which is equal to 2y, and then you're going to have 18 plus 40. So you're going to have 18 plus 40. That's equal to 58, right? Can you guys see this? And the reason why I can say that, because if you have a midpoint, that creates two equal line segments, right? Here and here, and here and here. So that's 2y is equal to 58, and you're going to divide this with 2. So 58 divided by 2 is equal to 29, right? So y is equal to 29, right? So once you know that y is equal to 29, and I think, yeah, this question only asks for y, but let's say you want to find what the dimension is from here to this point, right? So all you have to do is plug in 5 times 29 minus 18, right? So 5 times 29 minus 18 is equal to 127, right? So if this is 127, this needs to be 127 as well, right? Because they're supposed to be equal. So let's try to plug in 29 when you have 3 times y plus 40. So 3 times 29 plus 40. Yeah, so you're supposed to get 127 as well in order to just check your work, right? So 3 times 29 plus 40, this is also equal to 127. Okay, great. So for part 2, it says we have point G is a centroid, and we have the following dimension. So we have AB, we have AE, we have ED, and we need to find the missing segment measurements of BC. So maybe we can write that down. So we need to find BC, EC, FA. We need to find CD, CA, and EF. Okay, so they're saying AB is equal to 5, right? So this is 5. AE from here to here, that's equal to 13, right? And ED is 7. Okay, so as you can see, because we have a centroid, right? Again, there's going to be medians, right? There's 3 medians. So we have this line segment EB, that's one median. We have line segment AD, that's another median. And then we have line segment CF, which is another median. So in that case, if you have a median, you create 2 equal line segments because of the midpoint. So if you know that AB is 5, BC needs to be 5 as well, right? So yeah, they were asking for line segment BC. So that's why we know that BC needs to be 5. Okay, so if you have EC, right? So EC is over here. If they're saying your ED is 7, right? Can you guys see that? Yeah, if they're saying ED is 7, then that means your CD over here, so this is CD, this needs to be 7 as well, right? So that's done. Now, let's see. They're looking for FA, EF, and CA, right? So we can actually do CA first because we know that AB is 5 and we know that BC is also 5, right? So CA is actually 10, right? Because all we're doing is we're adding the 2. So this is 5 plus 5, so that's 10, right? And let's move on to this and this, right? So as you can see, we have 13 overall, right? So that's AE. But if you're looking at FE and AF, they're supposed to be equal to one another, right? But the problem here is they're actually giving you the total dimension as opposed to the individual dimension, right? So in that case, for AE, you would have to take 13 divided by 2, right? To get line segment AF, right? And line segment FE or EF, right? It doesn't really matter. It's the same line segment. Okay, so if you take 13 divided by 2, this is going to be 6.5, right? So you know that this needs to be 6.5. So AF or FA is 6.5, and FE or EF is also 6.5, right? So you know that the two are 6.5, right? And yeah, going back to EC, I guess we forgot about EC. So EC is just over here. So you know that this is 7 and this is also 7. Therefore, this must be 14. Okay, I guess that's the last question. For geometry. Yes. Okay, so this is what we'll do for next class. So for next class, we'll just continue on with the triangle centers and trying to figure out the dimensions, because apparently for medians, right, as you can see over here, you can actually find the dimensions as well, right, based on your centroid. And what else? We'll continue on with the slopes as well, right? And if you're interested, if you found this class to be really helpful, right? If you're interested in attending more classes with me, and we do have other talented educators who are also doing live classes and they're daily, and the best part is they're free, so you can actually check this schedule, right? So this is oneclass.com/livestream. This is LIVE. There we go. So yeah, oneclass.com/livestream. We do have our daily schedule over there, so please check that out. And also, if you know anyone who you think might benefit from this, who wants to also stay on top of their studies and be productive, please invite them to my classes and the classes of other talented educators that we have on our team. So yeah, thank you so much guys for tuning in and for just looking and listening to me just behind your screen. Yeah, I'll see you on my next class. Bye guys.